looked at finding greatest common factors of just numbers. Today we're going to look at finding a GCF of a monomial. These monomials have two parts. The first part is the coefficient. And the second part is the variable part. So what we're going to do is when we find our greatest common factor of these monomials, we're going to look at it in two parts. First thing we're going to look at is the coefficient part, which is just the number, and we're going to do that like we did previously in 5.1. Then we're going to find the GCF of the variable part. We have two methods. Method 1, we are just finding all variables that the monomials have in common and combining them. This ends up being the lesser exponent of the common variables. Remember, factors are always less than or equal to the original number. So for example, we're going to look at x cubed, y to the fourth, z to the fifth, x squared, y, z to the eighth. And the lesser exponents of the common factors. Well, we have an x here, we have a 3, and we have a 2. So 2 is smaller than 3. We have 1y and 4 y's. 1 is smaller than 4, so that's why we had the y. And then z to the fifth and z to the eighth. 5 is smaller than 8, so it's z to the fifth. Method 2, we can do this the same way we did method 2 in the last unit. When what we do is, and here's an example, we find the greatest common factor. We do kind of our factor trees here of 32, and then we have 3 x's and 3 y's. 40, here's the GCF we got from the factor tree, 2 x's and 4 y's. And then they circled all the common, what the two had in common, which is 2, 2, and 2. Each of them had 3 2's. Both of them have 2 x's, and both of them have 3 y's. And then we multiply what we circled. 2 times 2 is 4 times 2 is 8. And then we circled 2 x's, that's x squared, and we circled 3 y's, that's y cubed. And if we look, the x squared, if we look at method 1, it was just picking the smallest exponent of the common variables, which is 2 for the x, and it's 3 for the y. So let's look at a couple examples together. All right, we have 12x to the second, y, z to the fourth. Let's look at our numbers first. So we've got 12, and I'm going to do factor tree, which is 2 and 6. 6 is 2 and 3. 24, well, that's 2 times 12, and we just did 12, which is 2 and 6 and 2 and 3. So for 12, it's 2 times 2 times 3, and for 24, it's 2 and then 2 times 2 times 3. And now what do they have in common? Well, we have 2's, we have 2's, and we have 3's. So for our GCF, we're going to take 2 times 2 times 3. And that's 2 times 2 is 4 times 3 is 12. And now let's look at our x's. We have x squared, so for the 12 we have 2 x's. We have a y, and we have 4 z's. For the 24 we have 3 x's and 4 y's. So let's circle what they have in common. Well, they each have an x. They each have a y. So we have x squared and y. Notice that 12 has z's, but 24 doesn't. So our greatest common factor here is 12x squared y. Okay, let's look here at number 2. Do your factor tree and then come back and check to see if you have the right answer. Alright, let's see how you did. 21 is 3 times 7. So for 21, we've got 3 times 7. Then we have an A, a B, and 5 C's. For 35, that's 5 times 7. 2 A's, 2 B's, and 3 C's. 42 is 2 times 21, which is 2 times 3 times 7, 3 A's, 2 B's, and 2 C's. So now what do they have in common? Well, they all three have a 7. So our GCF is 7. And then let's look at the A's. Well, they all have just one A in common, so it's going to be A. How many B's? Well, there's a B. And then I believe I see 2 C's here. Now let's check. Remember, we're just taking the variable they have in common with the smallest exponent. Well, A, here's A to the first, that's the smallest exponent. Here's B to the first, that's the smallest exponent. And then C, we have a 5, a 3, and a 2. So there's our GCF.